recording on this group at the end or on the calendar? Because I couldn't find any calendar links on YouTube links on the calendar.
Yeah, so I will. So like when the recording has finished, so it takes a few hours to process.
Okay.
After that, so it will automatically be there in the calendar, the recording. I'll also make it available to view and download for all. But then, yeah, uploading it into YouTube will take some time. So maybe one day. After that, I'll share the link in the calendar itself.
Okay.
Yeah. All right. So the recording has started. So let's start. Okay. So basically, today we will try to cover regex, bash, scripting, sed, and awk. So we might not be able to cover everything in total depth, but we will be revising the concepts of regex, bash, sed, and awk. So let's start with regex. So I'm assuming like the basics regex is clear with you. So we will be following mostly the GNU documentation. So here you can see we have this page. I'll also send it in the chat. So we have this page. So if you go up, you can see that these are the everything given about regular expression. So we have two different kinds of regex, BRE and ERE. So we have seen that the difference between BRE and ERE primarily is that some syntaxes like the question mark plus round and curly brackets and the pipe symbol. So if you are using BRE, then if you simply type that symbol, then it is simply searching for that symbol. So for example, if I have, let me create a file which has something like a plus b. So if I do grep a plus b on the file, then the grep by default uses BRE. So it is using the plus as a literal symbol. So it is searching for the symbol plus. Whereas if I have a line, let's say AAB, and if I search for grep A plus B there, so it will only match A plus B and not the AAB. But here, if I now escape the plus, then it will match AAB and not A plus B. That is because now once we escape the plus sign in BRE, instead of matching the literal plus symbol, it will treat it as a special syntax, which in regex means one or more than one of the previous character. So here the previous character is A. So one or more than one means here the maximum possible is 2, followed by the B symbol. So in this, we don't have one or more than one A followed by B because we also have a plus symbol in between. So that's why this is not matched and only AAB is matched. Similarly, the same behavior is just the opposite in extended regex. So if you're using ERE, so that we can do by using a capital E in grep. So there, if I do A plus B, then by default, the plus means the special meaning of the syntax, which is one or more than one of the previous character. But if I want to match the plus symbol literally, then we have to escape it with a backslash. So in ERE, the escape plus means a literal plus. So this behavior is same for all the other symbols like question mark, opening and closing round brackets, opening and closing curly brackets, and the pipe symbol. So the plus symbol means one or more than one. The question mark means either 0 or 1. So either something is present or it is absent. So for example, if I have two phone numbers, let's say, and same number but with a +91 at the front. So I can match both kinds of phone numbers by providing a regular expression, which is of the format +91 being inside a group, and then I am providing a question mark here. So the question mark means either the +91 can be present 1 times or it can be present 0 times. That means it can be absent, but it cannot be present obviously multiple times. So in a phone number, we can only have one +91 at the start. And then we can have any digit present 10 times. If I do this, both the things will be matched, but here you can see the plus we are using as a literal plus, right? So this plus is not being matched because in external regex, the plus is taken as a syntax. So we have to escape it. So here you can see if you're using extended regex, then the plus has to be escaped if you want to treat a plus as literally. and this entire thing is a group. So the round brackets are groups, and the groups are there are multiple uses of groups. One is this one. As you can see, I can group the entire thing and use the question mark qualifier on the entire thing instead of just the one. So if I had not put a group here, this would simply mean starts with +9, and a 1 might be present or not present. So you can see the one without +9 1 is not being matched. So here I have to use a group because I want the question mark to apply on the entire thing or the entire group. And another use case of group is while matching back references. So for example, if I have a line here like race star, and I want to match something which is a palindrome, right? So this one is a palindrome. This is the same red left and red from right. So if I want to do that, one way to do that is using back references. So I can use groups and back references here. So I can say match any character and then match any character. And I do it for 3 times. So the first 3 character can be any character. The 4th character can also be any character, but I don't even need to group it because I don't care what that character is. The last 3 character then has to be same as the first 3 character in the reverse order. So then we can use the back references 3 to 1 to match for them. If I do this on the file, you can see that race car is being printed. Whereas if I have any other word, or let's say the first letter is capitalized in this, so that will not be printed because it is not the same front and back. So that is one of the use cases of the grouping with round brackets. And this can only work if you are either using extended regex or in basic regex, you have escaped them. So if you don't escape them in basic regex, then it will be treated as a literal round bracket symbol.
Can you do that in BRE also?
Yeah, sure. So if I remove the E, I have to simply remember that which symbols needs to be escaped. So for example, round brackets need to be escaped. And here, nothing else needs to be escaped. So the dot is always has a special meaning in both BRE and ERE. And the back references are already having a backslash. So if I run this now, you can see that we are getting the same result. So
and what if we want to search for n like a n big palindrome, like you don't know the length of the palindrome?
Yeah, in that case, it's easier to do using like reversing the string and matching if it's same front and back.
Okay.
So instead of using grep, that would be easier. So that we'll see when we are using bash scripts. So we have a command called rev. If I give any file to rev, it will simply reverse it. So you can see that only lines that are palindrome that read same front and back. So everything else read something else. Only this reads same. So I can simply see which lines are same when they are reversed.
So one question. So the first dot, the first 3 dots which are inside the braces,
Yeah.
that represent your first 3 characters, right? R,
Yes.
A, C.
Yes. Yes.
Then the fourth one, why you haven't kept it in bracket?
Because we don't need to back reference it, right? So I don't need that the 4th character be present any other time or any other place. So the 4th character is just the one in the middle. So this 5th has to be same as the 3rd, and then 6th has to be second as 2nd. But the 4th does not have to be same as anything. So we can also put it in a group that will not change the result, but it is not required. So even without it, it will work because we are not referencing it anywhere.
Excuse me, sir.
Yeah.
So the 3, 2, and 1 represent the group number, right?
Yes.
Okay.
Yeah, so this is the first group. So it's numbered from left to right. So this is automatically the first group. This is the second group. This is the third group. So then I'm telling after 4 characters, the 5th character should be same as the third group, which is the third character. The next one should be the same as second character. And the last one should be same as the first character.
Okay, sir.
So this is what the round bracket means. So this is grouping. And similarly, we saw that we can also use curly braces. So while we are matching this phone number, so we have used this curly braces. So another clarification. So these are not called braces. These are called parentheses, or sometimes also called round brackets, but mostly these are called parentheses. And these are called braces. So here we are using the brace to specify the number of times regex can be repeated. So one thing to note here is that 0 to 9, 10 does not mean that the same digit which matches the first time has to be there 10 times. So here you can see, even though the digits are different, it still matches. So this simply means that this will be 10 occurrences of 0 to 9. So each of them are independent of each other. So if the first digit is 9, the second digit can be 8 or anything else. So as you can see, this phone number, which is 98765432110, this matches with this. So here also, this is the curly braces we don't have to escape because we are using an extended regex. But if we don't use an extended regex, then we have to basically invert all the escapings of these characters, right? So question mark plus round opening and closing brackets, and then opening and closing braces, and then the pipe symbol. So you can see we have a round bracket, so we have to escape it. And here we had escaped the plus, so we do not need to escape it anymore. Similarly, we escape the, again, the round bracket, we escape the question mark. So the square bracket does not need to be escaped in either. And unless you are obviously trying to match a literal square bracket, and then the curly braces again needs to be escaped. So you can see in BRE also we are able to match the exact same thing. So this is the difference between BRE and ERE. So the last one which we have not seen is the pipe. So the pipe simply means either this or that. So if we have in the file, here we have, let's say, two words. One is apple, another is banana. And now if I do grep apple on the file, then only the line that has apple gets printed. If I do grep banana, it prints only the line that has banana. But if I want to match both the lines, which has either apple or banana, I can simply do apple, pipe, banana. And this pipe only works directly in extended regex. So here you can see both the lines, this one and this one gets printed, because for the first line, this part of the regex matches, and for the second line, this part of the regex matches. So this means either if this regex matches or if this regex matches, then we print the line. Similarly, without ERE, we need to escape this pipe symbol. You can see both these are equivalent. So we just have to note whether we want to use ERE or BRE. And for ERE, all these symbols, all these 1, 2, 3, 4, 5, 6, 7 symbols, they have a special meaning, whereas in BRE, they are treated as a literal symbol.
How do you check that two lines are equal and same?
I'm not able to hear what you're saying. The volume is very low.
How do you check that two lines are same or not?
How to check if two lines are same or not? As in like two lines present in different files, or?
No,
like,
no, same, like race car and race car.
Okay, so okay, so you want to see if let's say this line is equal to this line, something like that. So here, if you are, let's say, doing the matching with case insensitive, then both of these will be matched. But if you are, if you have a case sensitive matching, then only this one will be matched. So, for example, here if I do grep race car on the file, then you can see only the first one is being matched. And similarly, if I give a capital R, then only the second one is being matched. But here, if we give minus I, then both of them will be matched, because the minus I means case insensitive. So this way we can search for patterns without worrying about the case. So internally, grep will treat both the lowercase and uppercase as being same.
Actually, not this. Comparing that both the words are same or not.
Okay, so basically in the same file, you want to see which lines occur multiple times, right?
Yes, yes.
Yeah, okay. So for doing that, we will usually use the sort and unique command. So that we will come to it when we are doing the batch scripting. But to see it in short, basically, what you can do is you can use the sort you can use the unique command and the sort command. So if I sort the file, so you can see all the lines that are similar, that they come together, right? Because we are sorting it. So for example, if I have a race star here and then a race star here, after sorting, they will come side by side. So then we can use the unique command to get only the unique occurrences. So you can see both the race cars become one race star. But if you want to see if like how many number of times some line is there, you can use the unique C command to see that all these lines are present once, but this line is present 2 times. So this way you can see exactly which lines are present how many times in the file. Right, so we'll come to this in a few minutes. So hopefully this one is clear. What is the difference between BRE and ERE? So then we have the basics of BRE. So hopefully these are already clear. So if you have just any normal character as we were doing, so for example, if I just put any character in the search, then it will directly be matched as that character. And we have a few special symbols like the star symbol. So if you have the star symbol, that means any number of times the symbol before that can be present. So for example, if I give AP star LE, then this means that the symbol before the star, which is the letter P, it can be present 0 times or 1 times or 2 times, etc. So it can be present as many times as we want. It can also be present 0 times. So that is the difference between plus and star. So plus means 1 or more, and then star means 0 or more. So it can be present 0 times as well. And we've already seen that the dot matches any character. So like the A matches just A, and star matches, star is a qualifier. So it matches, it makes whatever was the previous character match as many times as possible. A dot itself is something that matches any character. So for example, if I do grep dot, then you can see all of these are matches. And although it looks like this entire thing is a match, this is actually 10 different matches. So this is one match, the 9 is a first match, then 8 is a second match, and 7 is a third match, because here we have only given one dot. So you can see what are the matches explicitly by using a -O. And what this will do is it will print only the matches, and it will print each match on a separate line. So this way you can see that each character is matched individually. So the word race car is not matched as one word, but each letter has been matched one by one. But instead of dot, if I give dot star, which means 0 or more, so it will try to match as much as possible. So if then we run the grep dot star on file with -O, so even if you're printing each match on a separate line, you can see that the entire line has been matched. So that is because the star makes the dot match as many as possible. So dot simply means any character. So dot star means any character, any number of times. So grep obviously matches only line by line. So it cannot match multi-line as one match. So on each line, it will match as much as there is. So that's how the dot star works. So we also have a few ways of matching the boundaries. So we have the line boundaries with caret and dollar, and we have also the word boundaries. So for example, if I have, let's say, 2 words, one is apple, another is pineapple. So here, if I do grep apple on the file, then you can see both apple and pineapple are matched. So this is also a very important thing to know, that if you're running grep on a file or sed or any regex, so it will match any substring of the line or word also. So if, for example, if you have numbers like 1 and 11, and if you do grep 1, so it will not just match 1, it will match 11 also. So it is not matching the 11 as one match, but it is matching the first one of the 11, and then it is matching the second one of the 11. You can see that if you do the -O, so you can see 1, 2, 3, 4, 5, 6. So there are 6 matches. So you can see 6 lines of ones. So all of these are individually matched, but they are matched nonetheless. So if you just give grep 1, it will match not just 1, but also 11. And even if you, let's say, ask it to match exactly one occurrence of 1, so this is still the same as grep 1. So this will still match the 1 in 11 and the another one in 11. So even if we give a pattern to match, the grep will match any substring in that line that matches that pattern. So let's come back to this example. You can see if I give apple, it will match both apple and pineapple. So there are a few ways to not have that. So one way is I can give a line boundary on both the sides. So I can say that match a line where the line starts, then we have apple, and the line ends. So this is only matched by apple, because in pineapple there is no such match. So the line starts with pine and not with apple. So that's why this is only matching for the line that has apple. But in sometimes we might not have just one word in a line. So for example, let's say this is a sentence. So in that case, if you do this, you will not get any match at all, because we are searching for a line which starts with apple and ends with, so it basically starts, there is the 5 letters of apple, and then the line ends. But there is no such line in the file. So in that case, instead of line boundaries, we will use the word boundary. So we can use \b, sorry, we can use \b to mean a word boundary. So here, although both apple and pineapple have the string apple in them, only the apple in this line is being matched and not the one in this line. This is because we have put a word boundary to the left and to the right of apple. So what that means is this apple in pineapple has to be a word of its own. So although here it is not a word of its own. So here we have a pine to the left of it. So that's why this will not match the apple in pineapple. It will only match the apple here. So this way we can match a whole word using \b, and we can match an entire line with caret and dollar. So if we just want to wrap our entire search with the caret and dollar or \b, there is also a easier way to do that. So I can, instead of using the \b's, I can simply give a -w flag to grep. So this way is how you do it in regex. So either way, whether you're using grep, sed, awk, anywhere where regex is used, this will always work. Whereas this is a flag of grep. So this works only in grep. So this is, you can say, kind of like a bonus feature that grep has. If you want to match only word boundaries, you can just give your pattern, and grep internally will put word boundaries around your pattern. So you can see here still we only get apple and not pineapple. If I remove the -w, then we get both the lines with apple and pineapple. But if I use -w, then we get only the apple. And similarly, if you want to match only the line that has just the word apple, so this will match both this line and this line. But if I want that line to only be the string that I'm searching, I can use -x to mean the caret and dollar at the left and right of it. So here you can see the entire line, the line that matches this is being printed. So these are different flags of grep that you can go through. So if you do man grep, you can go through the flags that are present in grep. So you can use extended regex, as we saw, using -e. And this is by default, you are using basic regex. You can also use fixed strings. So if you don't want to use regex at all, you can use fixed strings. So as we saw that in basic regex, plus is not taken as a special character. But let's say you want to also match something that you don't want to be taken as basic regex as well. So maybe hello.txt and hello2.txt. Both of these are there. So what happens if I search hello.txt in this file? What should be the output? If I'm running this grep here,
It'll search for hello.txt and hello2.txt.
yeah, right, because this dot here means any character. So you're not searching for the literal dot symbol, but any character. So one way is to escape the dot. If I escape the dot, then it means a literal dot. So it will only match hello.txt. But sometimes we may not have the ability to change the pattern. So for example, the pattern might be stored in a file and we are simply reading the patterns. So that can be done using grep -f. Right. So if, for example, if I have a file called patterns, and here I have put hello.txt. So maybe, for example, assume that this file is made available to you and you're not able to change this file. And if you're then just using grep -f patterns on the file, hopefully you're familiar with how this works. So you can directly give a pattern file to grep and it'll go over each line and treat them as separate patterns. So you can see that it is, because we have hello.txt there, it is taking as a basic regex and the dot is being meaning any character. So instead of changing the pattern itself, we can also use f here, which means fixed strings. So no regular expression will be used. So now if I treat the patterns as a fixed string, then only hello.txt will be printed. So this is very useful if you want to simply evaluate if some string is present in a line and not any regular expression. So,
So can you please explain it again? Capital F and small f, why you have taken both there?
Yeah, so small f means the file that I'm given after small f, that should be treated as a pattern file. So here the pattern file only has one pattern, but I can have any number of patterns I want. So here if I have, let's say, the word apple here. So if I run this with small f, so this will print all the lines that matches any of the patterns. So the patterns now is hello.txt and apple. You can see this line is matched with apple, so it's printed. This is matched with apple. This is also matched with apple, and these two are matched with hello.txt. So this is how we use -f to give a pattern file to grep, and it will go over all the patterns and print all the lines in file that match any of the patterns in patterns. But here, this is by default using the basic regex. So if I want to treat these as strings and not regex, so here this dot is meaning any character, right? That's why we are getting hello.txt and not just hello.txt. If I want to treat this as strings and not regex, then we can use the capital F, as you see in the man page. Capital F means fixed strings. So then it is treating each of these patterns as fixed strings, and we are only getting hello.txt and not hello.txt. And hopefully this makes sense. Okay, so we just now saw how we can also match if some string is present as the only thing in that line. So here we are matching apple with this one also, and this one also. But if I only want to print those lines that are only what the pattern is given, so only apple and not the other two. So remember, we can use x here. So the x can be present here also. It can be present here also, because the x does not take any argument, but the f takes an argument. So the f has to be before this pattern file. So I cannot give ffx here, because then the argument to the small f becomes x, which is not a file. So I can put the x anywhere else. So this x means that the entire line has to be matched. So if I run this now instead of this, so if I just run this, we get all these 4 lines. But if I run this, we get only those lines that match exactly what is given in patterns, and that is the entire line. So it cannot have anything to the left or to the right of it. So this is how grep works internally. So the patterns is treated as a pattern file, but then we are using fixed strings, so it's not treated as regex, it's treated as normal strings. And it tries to match substrings, but then we have given x, so it matches only entire lines, which like it prints only those where the pattern matches the entire line. And we are taking this pattern. So here this is treated as a pattern file, and this is treated as the file to search on. But once we are doing it this way, can you see what kind of symmetry or a different utility comes out of this? So if I am using grep -fxf, then what happens when I give 2 files here? Okay, so let's say the first question is, what happens if I change the order? If I make it file and patterns, what will happen? Will it throw an error? Will the output change? Will it be same?
It should be same, isn't it?
Yes, it should be same, right? Because firstly, internally grep is treating these two as separate things. So this is being treated as a file to search on, whereas this is being treated as a file which has patterns given line by line. But because we are doing all these things, because I'm matching the patterns also as normal string, and I'm matching the entire line, so that's why both of these will be symmetric. So here you can see the output will remain the same, but the order will be different. So here the order depends on how it is defined in the file. So in the patterns file, because hello is defined before apple, that's why the output hello comes before apple. Whereas in the normal file, the apple is present before hello, that's why apple comes before hello. So the order will depend on the file that is given to it. So here in this case, the file is patterns, and here in this case, the file is file. But the output will be same, and it will be symmetric because of these options. So then what does this do? So we know what each of these options do, but then what is this entire thing doing? So if I give grep fxf file 1 and file 2, what is the output signify? Any ideas? So this is basically the file 1, and this is the file 2. And on running this, I get this output. So like without going into details of specifications, in basic, what does the output signify? Whether it is in this order or it is in this order, what does this do? So we already saw it is symmetric. So it doesn't matter which order we give the files.
I think the hello.txt comes before in the patterns, right? That's so it's searching first for hello.txt in patterns.
Yeah.
And then it's searching for apple. Then it's matching apple.
Yeah. It's searching for all of these, but then it's finding hello.txt first. So it's being printed first. Yeah. So that is fine. But then what does this entire operation signify? So for example, if I give any file here, so file 1 and file 2, so what will be the output of this when I give any two files in here?
Common lines between the two.
Yes, right. So this prints the lines that are common between the two. So because we already saw it is symmetric, so it doesn't matter which order we give it in, and it will always print the common lines between the two. So we also have a way of inverting matches, so that we can do by using the -v flag. So not the capital V, but the lowercase v. So if I give a -v on grep, then it inverts the matching. So it will only print those lines that don't match. So then what happens if I put a V here? So let's say I have patterns and file. So what will this print?
Uncommon lines between the
This
two.
is like diff. It's like diff.
Okay, so uncommon lines, but will it print the uncommon lines of both the files?
I think it will print only the files of patterns.
Okay.
It will print those lines of the file which do not contain the pattern.
Right.
Okay. Yeah. So it will actually print those lines in file which are not present in pattern. So you can see all these are printed, but the line of apple and hello.txt are not printed. So in this case, this is no longer symmetric. Here, if I give it in this order, patterns and files, then this will be the output. Whereas if I give file and patterns, then what shall be the output?
So this is like a subtract operation.
Yes, yes, exactly. So in this case, what output should we expect?
Pattern minus file.
Yeah. So what will that be?
Blank.
Yes, it will be empty, right? Because there is nothing in patterns that is not there in file. So everything that we have here is also in there. So if I change the patterns, then we can see something. For example, here if I add orange, so now we have one line which is not there in files. So then if I do this, then it will only print that line. So this is a very nifty way of finding three things. So one is a intersection, sorry. We can find A intersection B, we can find A minus B, and we can find B minus A. Right, so three things we can find. We cannot find A union B this way, but that is fairly simpler to do. So intersection we saw, we can do directly with grep fxf and then two files. And A minus B and B minus A, we can do by simply inverting the match, so VFXF, and the order of the files provide which will be printed. So if it's grep VFXV AB, so it will be B minus A, and if it's BA, then it will be A minus A. Right. So let's also see, because we're already in set, let us also see how we can print the union of two lines or two files. So if I want to print everything that is there in file and print everything that is there in patterns, so the easiest way I can simply do cat file and patterns. Right? So because cat can take as many arguments as I want, and it will print them one after the other. So if I do this, then you can see the output will be, so this is a specialized cat that I have. Let me use the default cat. Yeah, so you can see that the output will be all the lines of file followed by all the lines of patterns. But here you can see we also have the duplicate. So the hello.txt is present here and it is also present here. And similarly, the apple is present here and it is present here. So there are a few ways to get rid of duplicates. So if you are not interested about the order of the output, so which is the case when you're working with sets, right? So sets are unordered collection. So in that case, what you can do is you can simply sort the output, like the total output of this cat. So the total output is entire thing. So if you sort it, obviously the common things will come together, and then you can use -u or you can pipe it to unique to get only the unique entries. So this will not just remove the duplicates across files, but also duplicates inside files. So if I have some line present 2 times inside one file, so as you can see here, race car was present here and race car was present here. So those duplicates will also be removed. It's now present once. And also cross-file duplicates like Apple and hello.txt, those are also removed. So Apple is only present here and hello is only present here. So this is one way of getting union. If you don't want to change the order, then we have to see some other, you have to actually implement proper algorithms so that you can do either in awk or you can do with bash scripting. So we'll see that when we come to awk. Hopefully this one is clear.
So what you said, this this special version of cat, is it? I mean, escape character cat.
So yeah, so so if you are typing cat, for you the output will be like this, but I have my cat alias to something else. So my cat
Is
is
it? Okay,
alias to some other command. That's why I'm getting that.
that's right. Okay.
All right. So let us.
Sir,
Yeah.
sir, this web, just open that web page only right now.
Yeah.
This, how can we get this in using man and info? What command to type?
If you type info sed, then
Okay.
you get this info page. Here you can come to this regular expression, right? So you can press enter here, then you get this same page. Right? So this is the page we were seeing earlier, BRE versus ERE, and then this is the page we are seeing now. So character dot caret, etc.
Okay. Thank you, sir.
Similarly, you can also go through any other info page. So for example, we have info grep, right? So info page usually have more details than man page. So man is a very concise manual that will only give you like the important parts, but info will also teach you a lot of things. So this is kind of more like a book. You can see here in grep also we have a chapter on regex. So you can go through. So you can see these are the sub chapters on regex. So here also we have the difference between basic and extended, what is anchoring, etc. And go through the chapters on the info page of grep and set.
Yeah, right, sir. Thank you.
And for awk, prefer to use the gawk, which is GNU awk, because it will have more information than just the awk. So if you open the gawk, you can see that it will have a lot of like information. So these are the 3 important things: sed, grep, and awk. And for bash also, you can go use info bash. So it will tell you all the things about bash, like shell features, shell built-ins, shell variables, job control. So a lot of information is given in this. And you can also use man bash. So this has a less number of information, but in a concise manner.
Excuse me, sir.
Yeah.
Is geoc and moc same? Because geoc is not in my laptop.
What do you have? MAwk.
Yes.
So okay, so I don't have MAwk on my system. I'm not sure what that is. Most probably it's another flavor of awk. So there are different flavors of awk. So on your system, you have to see what is the like how is awk defined. So if you do real path awk, you can see that. Sorry, not this. So So if you do real path which awk, my bad. So then you can see, for me, it is symlink to user bin go. So this is GNU awk. So this is, you can say it has more features. So if in your system it is symlink to mawk, then it will be the different version of awk. So the basic things that are there in awk, that will be there in both of them. But the things that are there only in gawk, that will not be there in the, that may or may not be there in the other implementations of awk. So if you're in the VM itself, like the course VM, there also you will have gawk. So once again, let me just check. Yeah. So if I do real path which awk, you can see in this VM also it is symlink to the gawk. Okay. So that is the basics of grep. So let us also quickly go over the box notations, and hopefully you are familiar with the other things of that. So as we saw, we have done the 0 to 9. Okay, not here. Okay. Yeah, so we have used this 0 to 9 to mean any digit. So similarly, we can use any character here to basically mean any of the characters present in this square bracket. So for example, if I put A here, then it will match any instance of 10 A's consecutively. So let me remove all this. So let me just match A. So you can see all those lines that have A are being printed. If I now do A, E, then this means print all those lines that either have A or have E. So the match will be either A or E. You can see both A and E are being matched. So this way, if you want to match multiple characters, so you cannot match multiple phrases or words this way, you can only match multiple characters. So if I want to also match, let's say, the dot symbol, so I don't have to escape it inside this square bracket. So inside this square bracket, the dot means the literal dot and not any character. Because obviously, if you have a like special syntax dot inside the square bracket, it makes no sense. That will basically match every character. So putting a dot inside the square bracket automatically means the literal dot symbol. So here you can see it is matching the A's in the file, it is matching the E's in the file, and it is matching the dot symbol in the file. But if you want to match like multiple words, then you cannot do it inside this. For example, if I want to do apple and banana, you can see this will not work. This is basically same as matching all the letters given here. So it is matching apple, obviously, because all the letters I mentioned here are there. But it will also match these letters here. So this is not the correct way of matching that. And you can see it is also matching pineapple except the letter I. So it is not even matching all these as one match. It is matching each of the letters as a separate match. You can see that if you do a -O here. So these are all separate matches. So if I want to actually match multiple words, then I have to use the pipe symbol. So this way we can match multiple phrases. But if we want to match multiple characters, then we can use them in a box bracket. And if you put a caret before any other symbol in the box bracket, then it is a inverse matching. So for example, if I do a box bracket AEIOU, this means match all the vowels in this file. But if I do caret AEIOU, this means match all the consonants or not just consonants, any other character which is not a AEIOU. So you can see the numbers are also matched, the dot is also matched, and consonants are also matched. So anything that is not a vowel is being matched. So don't confuse the caret here with the caret outside. So if we have a caret outside, that means the start of the line. So now we will only match the characters at the start of the line that are not vowels. So you can see from here the lines like apple are not printed anymore. So if you see the file here, we have some lines like this apple, apple. So these are not being printed because in that line you don't have any character which matches this regex. So earlier it was matching the other consonants in this line, but now that I have told it that it has to match the first character itself. So the start of the line should be a consonant or non-vowel. So then this line is not being able to match, because in the start of the line, we only have A, which is a vowel. So only lines that start with non-vowels are being printed. Right, so hopefully this is clear. So now if I want to, let's say, find out the numbers inside the file. So for example, I want to print only the digits in that file. What I can do is I can use grep to match the 0 to 9 in the file. So you can see that the digits are printed here. But if I want to print only the digits and not the things to the left and right of it, then I can use -O. So then it will print only the matches. But here you can see every digit is matched separately. So we get every single digit one by one on a line.
Sayan, could you repeat the last one?
Yeah, sure. So if I want to match digits in a file, I can use 0 to 9 in a box bracket, and it will match all the digits, but it is matching them separately one by one. Each digit is its own match. So if I don't want to print whatever is there other than the match, so for example, I don't want to print hello and txt, I just want to print the two, then we can use -O to print only the matches. But what happens in this command, which we have done, is we are matching a single digit. So each digit is being printed on its separate line. So we don't want that. We want this entire thing to be one line, and this 2 to be one line, 1 to be one line, and 11 to be another line. So for that, instead of matching one digit, we should be matching one or more than one digit. So then the plus will mean match as many digits as possible. So then you can see the output, if you're using -O, will be only the digits in that line and not whatever we have to the left and right of it. Right, so
what about the first two lines of output?
Yeah, these are also the digits in the file, right? So if I see the file, we have this, right? So yeah, so any digits, consecutive digits.
The matches, matching characters.
Yeah.
Not the entire line or the entire word.
No.
Not the entire line. Okay.
No. Yeah. So now in this file, let's say I have a line with multiple digits, but separated by something. So for example, I have 1, hello, and then 2. So then if I run this, you can see that 1 is being printed and then 2 is being printed on a separate line. So that is because we're using -O. So all the matches will be printed on separate lines. So here it is printing on the same line because these are consecutive digits. So it is directly being matched as one match. But here, because they are not consecutive, it is not able to match them consecutively. So here if I have some other numbers with them, so the entire number will be matched as one match, but as soon as we have any non-digit character like space or letters, then the match will end. So this is where the first match ends, and then the second match starts from here and ends here. So the matches will be printed on separate lines.
Okay.
So for example, if I don't want to print lines that have multiple numbers, I want to print only the lines that have a single number. So in that case, what we can do is we are matching already for multiple digits, but I also want to match that anything to the left of that on that line should be a non-digit, and anything to the right of that on that line should be a non-digit. So I can do something like caret 0 to 9. So this means any character that is not a digit, and I can match that as much as possible. And similarly, on the right of it, I want to match not a digit, not 0 to 9, as much as possible. And I want this to be the entire line. So I can basically match the start and end of the line. So here you can see all those lines that have only one consecutive number are being printed. And all the lines that have multiple numbers, like this one, which has multiple numbers, is not being printed. So only lines that have one consecutive group of digits that are being printed. But here, because we are now matching all the other digits also, so we don't get just the numbers as the output, we get the entire line as the output. So then we can simply extract the numbers by using another grep. So we can pipe the output of this grep into another grep, and here we can simply match the 0 to 9 again. And here we can use -O to print only the numbers. So this way we can print only the lines that have only one number or only one consecutive group of digits. So even if here we have two consecutive groups of digits, it's not printed because we are matching that the consecutive groups of digits should have consecutive groups of non-digits to its left and consecutive groups of non-digits to its right. And that should be the entire line. So we are not allowing any other digits to be present in that line. Right? So that is basically what regex is and how you can use grep to search for regex. So regex does not stop in grep, but we will be using regex in sed and awk also. So we will see also some other parts of regex when we are going over sed and awk. So let us move forward with bash scripting and see a few things that is important in bash scripting while doing the OPPE.
Sayan, where is this question available, Sayan?
Which one?
The notes or the PDF that you have shown now. Is it
This
available?
one?
Yeah, this one.
This is part of the GNU sed documentation. So you can do info sed and all the pages of the documentation will be present here. So we are going over the regular expression.
Okay.
So let's go over a few important concepts of bash scripting also. So for example, you might be asked to create a script.sh. So first thing is we will obviously be using some text editor, either Vim, Nano, Emacs, whichever you're comfortable with. So I'm going to be using Vim, but feel free to use any text editor. So the first thing which we do is we create a shebang. So the shebang is not compulsory. It is required when you are running the script using directly the /. So the first thing to do when you are creating a script is, let's say I have keyword echo hello here. So the first thing to do is make it executable. So we have to do chmod u+x script.sh. So normally the permissions will be rw -r'. So if I do u+x, then the user's executable will be set as yes. So it becomes rwx r'. So now that it is executable, I can now execute that using /script.sh. So you can see it is now printing hello because I have told echo hello. So when I'm running it this way, I'm not telling my shell how to run this. So this is just a file. So I'm not telling it how to run this. If I run, let's say, bash script.sh, then I'm telling my shell that run the bash command and give it the argument as script.sh. And bash itself takes a file optionally and it can run that. So in this case, I'm simply calling the bash and giving script.sh to it. So obviously this will be run as a bash script. But if I am running it as /script.sh, which is only possible if this is set as executable, then my shell does not have any way of knowing how to execute this. So for my shell to understand which executable to use to execute this, we provide this shebang. So this starts as a comment. So this looks as a comment. But the first line, if we have a comment and a bang symbol, so this is she and bang, so shebang. So in the shebang, we have to provide the path of the executable. So if I don't provide this, then also it will work sometimes. So for example, right now I am using bash. So if I run a script which does not have any shebang, so by default it will run as bash itself. Similarly, if I am, let's say, in a different cell like ZSH, and I don't know why the prompt is this way. So anyway, so here if I do /script.sh, so here it will be run as the ZSH itself. So for example, here if I do echo shell, so you can see that here the shell is bin bash, but if I run this from here, okay, so in both the cases here the shell is bin bash, but if I use some things that is present only in bash and not in other shells, then this will cause an issue. So for example, we have two ways of using if conditions. We can either use a single box bracket, which is a executable or a command directly. So you can see type of the square bracket. So it is executable present in /bin or /user bin. But we also have a bash version of this, which is double square bracket. So this has some extra features. So if I use this, this is only available inside bash and also inside ZSH, but not inside the POSIX sh. So in that case, we have to strictly make it clear what shell we are using. So for example, if I state that this is sh script, so here if I, let's say, I ask something like this, so you can see that here the issue is in POSIX sh, the double square brackets is not defined. You can only use single square brackets in POSIX sh. So if you want to use double square brackets, etc., and all the other things that is available only in bash, you should always set this to bin bash. So for example, the extension of a file never matters. So even if this is script.sh, this can be any kind of script. So for example, if I remove all this, I can also say print hello. So if I run this directly as /script, you will see we are getting an error because this is not a valid syntax of bash. But here, if I now provide a bin Python, so then you can see that it is working properly. So this way is to like this shebang is to mention what interpreter to use. So here I can do any Python scripting that I want. So even if the file extension is anything, it can also have no extension at all. So the shebang is used by the shell to see what kind of script it is being run. So here I can use like all the things that is available in Python. I set it to bin Python.
And what does this bin means? I mean,
this is the path where your executable is present, right? So /bin/Python. So if you go to /bin, you can see you have all the binaries of your system here. So one of those will be Python. So I cannot find it right now, but it should be there somewhere. So all your binaries are there. So if you see what is Python, you can see Python is a binary that is present in /bin Python and /sbin Python and /user bin Python. So if you set it to anything, so for example, if I set this to user bin Python, then also this will work. And if I set this to sbin Python, then also it will work. So it has to be a valid path to some interpreter and it will automatically run that. But here, let's say I set this to something like rbin, which is not a valid path. So then you can see that it will say cannot execute required file not found. Right. So you have to give a valid path to an executable.
Right.
So
and by this shebang line, we make it as an executable file, is it?
Yeah. So if you want to like run a script this way, right, using /, so then that file has to be set as executable. You cannot run
and
it.
This is the line by which you make it executable. Shebang
No.
bin bash.
No. To make it executable, we use chmod u+x. If I'm using chmod, it changes the permissions and I'm setting the execute permission, the X permission. So I'm adding the execute permission for the user. So we are doing this. This is just to let the shell know what basically executable to use. Yeah, what interpreter to use to run the script. But to make it executable is something you have to do on the file system itself.
Yes, correct. Okay, yeah, thanks.
So now if I set it to bin bash, I can now use bash commands here. All right, so here you can see that this is how we run a bash script. So a few important things like taking input. So let's go through those. So for example, the question may say that the input is given to you as standard input. So for example, if I have the output of ls, I can pipe it into my script. So this is how I run that. So obviously in this case, we're not reading the standard input. So whatever I give as standard input, the output is always hello. But we can also change that. So for example, I can read one line and then I can echo that line. And you can see that the output is the first line of that file. So even if I create, let's say, a few files, a.b. So now I have 5 files here. I have A, B, C, D, and script.sh. Even then, the output of this will just be one line because read will only read the first line from the standard input, and all the other lines are ignored. So if I want to read all of the lines, then I have to use a while loop to go through to iterate through the standard input as many times as there are lines present. So then I can do while read line to echo line. So this is a very simple script which does nothing at all. So it will read your standard input and print that to the standard output. So this is same as not having the script there at all. So if I do ls pipe script.sh, you can see all the things that is printed by ls, all the separate lines that is being printed by the script.sh. But now that we know how to take input from the standard in, we can use this to perform a lot of different actions. So a good practice is to always use the -r flag with read. So if you don't have the -r, so what happens is, let's say I have a file here and the file has some words. And if I, let's say, put a backspace here. So what happens is if I, let's say, do cat file and pipe it to our script.sh, so the backspace, sorry, this is not backspace, this is backslash. So the backslash gets omitted. So you can see from the output, it is no longer there. So we should always use a read -r to prevent that. So if I run this now, you can see the backslash is present, it is intact. So whenever you're using read, ideally it will not make a difference if your input does not have any backslashes. But to be safe, we should always use a -r so that these droppings are not done. Right. So this way we can go over all the lines of standard input, and we can also do some tasks based on that. So for example, let's say I have a list of file names here. So I have A and B, and remember that we have files A and B here. So let's say in A, I type something like this is file A, and in B, I type this is file B. And what I can do is I can go over the standard input, and I can then, instead of echoing that, I can cat that. So now if I do cat file pipe./script, then the output becomes this is file A, this is file B. So this is because the file has two lines, A and D, and I'm printing the output of that file and piping the output to script.sh. So the script.sh is reading each line using this while loop one by one, and each line is stored in this variable line in each iteration. And instead of printing that line, I am sending that line to cat. So if I give a name of a file to cat, it will simply print the contents of that file. So you can see this both the files A and B have been printed out.
So I have one doubt here.
Yeah.
Dollar line, what it will do? I mean,
so dollar is a way of accessing the value of a variable. So line is a variable. So if you just do line, then this means you are basically, let me show it with echo itself. So if I do echo line, then this will simply print line. If I don't want to print line, I want to use the value of line. So if I do echo dollar line, then I'm taking the value of line. So the value of line is being changed in each iteration, right? So it's coming from the standard input. So here, then we are getting the correct values. So now instead of echo, if I do cat, then it will print the values of those files.
So we are giving the contents of file, the output of the cat command to script.sh.
Yes.
And it reads line by line, and it prints.
Yeah. So for each line, we have name of a file, and we are then giving that name of a file to cat. So cat is then printing each line one by one. So I can also do some other things. I can say echo line, and then I can, let's say I can do echo all these pipes, and then I can print the contents of that line. So this will also put a header that this is the file. Or I can also say that the file is this.
So instead of echo command, we can use cat also, is it? Because typically I have used a cat for listing the contents of file.
Yeah, that is what we're doing, right? So these are the files A and D. So as I showed, we have these files A and D, and the A has this content. This is file A, and D has this content. So I just added it a few minutes ago, right? So the cat is printing the contents of the file, and echo is printing the name of the file. So if I run this, so you can see file A. So this is because I have written file and then $line. So this is printing the name of the file, whereas cat is printing the contents of the file.
Okay.
And what is read minus are doing?
So -r prevents dropping of the backslashes. So as we saw, if your input has a backslash, that backslash will be dropped if you don't have -r. If you don't want read to drop backslashes, we should use -r here.
It means escape characters will also be taken into consideration.
Yes, yeah.
Okay, but -r, does it have some acronym like?
So in read, -r does not have any like long version. So -r basically what it will do is it will not drop the backslashes. Yeah.
Read the entire contents of the file, including the escape characters. That's what we can implicitly understand, right?
Yeah. Do not read backslash in a special way. Consider each backslash to be part of the input line.
Is it only for backslash character or all special characters?
No, it is only for backslashes.
Okay. -r is only for backslash.
Yeah. Yeah, so you can see this way we can go over the standard input, and then for each line of the standard input, I can print that line, and then I can try to access a file with that name. So here what we are doing is we are assuming that we are reading from standard input, and then but while calling, we are calling like this. So instead, if I call it this way without giving any standard input, then the default standard input is your terminal. So here, whatever I type, that will be taken as a standard input. So for example, if I type A here, it will print file A. This is file A. So this is one iteration of the while loop. Again, it is stuck here. So this is waiting in the read for your next input. If I give B, so remember that the file B was empty. We did not add anything there. So it will then say file B, and then it is empty. Again, it is waiting for your input. So you can give C. And if you remember, the C was also empty. And if I give D, then it says file D, and this is file D. So we can keep on running this. So
how to put a completion of this? Do we need to give Control C something, or?
No, so Control C is for stopping a command altogether. So for example, here if I have something like if I print done here, right? So if I do Control C, so you can see if I write A, it prints this. If I write D, it prints this. If I do Control C, you can see this is not being printed, right? So this stops the script altogether. So this is not what you want. You want to end, like stop giving the input, right? You want the while loop to stop. So if you want to stop giving input, you should print. You should press Control D. So Control D means the end of the input. So then this while loop stops, and you are getting the done being printed.
Okay, here in this particular case, the interpreter reads the Control B, and it will stop accepting input from us.
No, in all the, so in Bash, always if you're using Control D, so if you are taking input from standard input, if you press Control D, it always means that it is a end of giving the input. If you just run Control D, well, nothing is running, it will close the terminal itself. But if you are basically like running a script which keeps on taking input as long as there is an input, so then you can press Control D to stop giving the input.
Okay.
Right, so this one is like by default, the script is taking the input from standard in, but we were running it by using the cat, so it was taking the input from the file. But now let us see how we can directly take input from a file. So if I run this script normally, it is now blocking my terminal and waiting for me to type an input. So this might be useful in some cases. For example, if I want to keep on giving input as many times as I want, but if I don't want that, and if I directly in the script, I want it to iterate over some file, what I can do is I can add a left angle bracket and the name of the file. So what this will do is it will take the input, like the standard input of this while loop, not from the standard in, but from the contents of this file itself. So now I don't need to use cat file anymore. I can directly do script, and you can see it automatically reads the lines present in the file named file, and it will iterate over all the lines of file. Right, so this is how we can take input from a file on a while loop. So we can also do it by using cat file here, but instead of doing this, we should prefer using the left angle bracket, because this is calling another command, whereas that is handled directly by bash. So it is more efficient. So you can see the output is same, but this is a more efficient way of doing this. So this will take a few milliseconds less time.
Is there a possible way to give the input from a file? For example, your file, the name of the file is defined already. But in case if we want to write a script where we do not know the name of the file in advance, we're taking input from file, whatever the user provides. So in that,
you can already use what we are already using to do that, right? So we already know how to take input using the read. So you can use read to take, so let's say I can use -p to give a prompt. I can say enter the file name, and I can read the input from the standard in from the user, and that I will store as the variable file. So then, because now this is a variable, I can, instead of hard coding the name of the file as file, I can use the variable and I can iterate over that file. So for example, let's say I rename this file to be list of files, and I copy this list, I copy this list of files to be list 2. And in this list 2, instead of A, B, I have, let's say, B and C. So we have 2 lists here. We have, oh, sorry, I did a move, not a copy, my bad. So let me create list 1 also. Here I have A and D. Right, so we have 2 lists here, list 1 and list 2. List 1 has AD and list 2 has BC. So now we are taking the input from the user itself. So if I run this script, it is telling me enter the file name. So here if I give list 1, we can say it's iterating over list 1, and A and D which are stored there, those are being printed. But if I now type here list 2, you can see it's iterating over the contents of list 2, which is B and C, and it's trying to print the contents of B and C here.
Yeah, got it. Thank you so much. So for read, mainly the prompt, the options that we need to keep in mind would be -R, -P, or any other which are really to read.
No, so mostly it is, so R is just for safety. So if you have a backslash here, and a P is if you want to give a custom prompt. So if you don't want to use P, you can also use like echo or something. So I can also drop this, and I can do something like echo enter file name. So we can also do this. So echo by default will go to a next line. So you can see the line ends here and our like this is here. So this still works. If you don't want it to go to a new line, you can also add a -n here. So this way I can say enter the name of file and I can put list 1 here. So we can use echo to send the prompt, but it is more convenient to directly do that using the P.
Okay, and then we just give the variable name after the file. Yeah, okay. Thank you.
Okay, so that is how we use read, but read can also read multiple variables. So let us see that now. So for example, let me create a data.csv file. And here I have, let's say, a few data present. The data needs to be in a structured manner, like exactly 4 columns always. So here what I can do now is I can say while read, let's say column 1, column 2, column 3, column 4, 2. So what this will do is it will try to read 4 things from each line. So here I can simply say things like column 1 is column 1, and similarly I can do for column 2, column 3, and column 4, and I can then do done, and I can take the input from the data.csv. Right, so can anyone notice any something that we have forgotten to do in here, or why this will not work as of yet?
Field separator, sir?
Yes, yes. So the field separator is comma, but read will only separate by the spaces. So I have to also set the field separator. So here I have to set IFS equals comma. So if I set IFS equals, sorry, not here, my bad. Has to be either you can do it outside, so you can do IFS equals comma outside, or you have to do it after the while. So now if I run this /script, so you can see all the columns are taken correct. So I can also, let's say, demarcate each line. So I can say a new row, and I can put maybe some lines here. So you can see for each row we are getting column 1 is 1, 2, 4, 5. Then next is 5, 2, 1, 6, 5, 2, 6, 2, 2, 5, 2, 6. So it's able to read each of the separate columns in separate variables, call 1, call 2, call 3, call 4. And here, because the field separator is comma and not space, we have to specify IFS to be comma. But here the issue is we are changing the value of IFS. So later, if we are doing some for loop or something like that, or another while loop, this will still remain as comma. So that is something we should not do. One thing you can do is you can remember the old IFS. So you can say old IFS equals IFS. So you're just storing the value of that variable in some other variable. And after doing this, you just reset it. So you can say IFS equals old IFS. So if you're changing the IFS outside the loop, make sure you if you don't set it back and you're not doing anything in the script, then it is not an issue. But if you're doing something after this while loop also, which uses the IFS, then you might have some issue. So you can change the IFS back, or what you can do. So here, let me show you what happens. If I do echo IFS, so you can see that here the value of IFS is now not there. So the better way to do this is instead you can put the IFS equals comma inside the while loop. So if I run this now, you can see it is still working, but here I have set the IFS inside the while loop itself. So it will not basically do it outside. So only while running this read command, the IFS will be changed. So that is exactly what we want. We don't want the IFS to be changed globally. We only want the IFS value to change for a particular variable. And this way of setting a variable's value is not just inside while, but you can do it for any thing. So for example, if I do, let's say, echo $ABC, so ABC is obviously unset. So if I echo ABC again, it is still unset. So if I set ABC equals something, then it will be set in this entire shell. And whenever I do echo ABC, it will be there. But if I, let's say, set the value of ABC, and in that same line, I do echo ABC. So notice that there is no semicolon here. This is part of one command. So here you can see that, okay, this is not working. Sorry, 1 second. So let's say, instead of, let me create another script here. And here, let me echo the value of ABC. So if I make this executable, and now if I simply run this s.sh, then you can see it is empty because the value of ABC is undefined. If I do ABC equals 1, 2, 3, and then I do the ./s.sh, then you can see that it is printing 1, 2, 3. So the value of ABC is set, but only for this like this script call. If I now print the value of ABC, you can see it is still undefined. So this way of setting the value for only one executable, putting it in the same line without putting any semicolon. So this way, the value of ABC is only set for this subshell and not after this. So even after, if I print ABC, it will be empty, and only while calling this will be set. So you might have seen some questions in which you're assumed to, like, you're told to assume that a variable or environment variable will be set. So this is how it is set. So it will be set before calling your script, so that when your script is running, it is able to access that. But outside that, that variable is again not defined.
Sir, is it like providing a constant value or a static value in the same program? What kind of questions will be asked here?
So you can change the value, so that is not constant. So for example, I can echo this, then I can say ABC equals, let's say 4, 5, 6. and I can print it again. So it is not a constant, but this is being only set for this execution. So the value of ABC will be undefined outside this. So only when this script is being run, you are getting the value of ABC. So you can overwrite it, but by default, you will have this value. So let's go back to the script that we had. So here we are setting the IFS to be comma. So the read is correctly setting the IFS. So don't confuse IFS with only FS. So in awk, we set FS to set the input field separator, whereas in bash, we set IFS for the input field separator. So here we are taking the input from the data.csv. We can also redirect the output of this entire while loop to some other file. So for example, if I redirect this to output.txt, so when I run this script, there will be no output to the screen. So the screen will be empty. But you can see we have now got another file here called output.txt. So let me remove this star message. If I cat this output.txt, you can see everything that this while loop prints, that entire thing has been stored in that output.txt. So if I, let's say, print something else after this, that will still be printed to the screen, but the output of the while loop is redirected to the output.txt. So we are taking input from this file as standard input, and we are redirecting output as standard output to this file. So this is one of the important ways of taking input in while loops. We also have a for loop to iterate over items where we know exactly how many items there are. So one important use case is iterating over the arguments, right? So one way we can do is we can iterate over numbers this way. So for example, if I do echo I, and if I run this script, so you can see it is printing each number one by one. So what is this curly bracket 1.10? So this will be expanded by bash itself. So you can see if I do echo 1.10, this is expanded into the 10 numbers. So it is 1 space 2 space 3 space 4 space 5, all these. So it starts from this and it ends at this. So both of these are included. And I can also add a step. So I can do .2. So then it will skip that many. So from 1, it will then directly go to 3. Then from 3, it will go to 5, etc. So this way is directly inside bash. So it's not any other executable. So you can use it to go over like numbers or items in a sequence. We also have the command seq. So seq will print the multiple lines based on what you give. So for example, if I give seq 110, it will print the numbers from 1 to 10 in each number in a separate line. So we can also give any other number like 515. It will print from 5 to 15. And I can also give a step. But here we have to give the step as the second argument. So for example, if I do 5 to 15, so it will be 5 and then 7, 9, 11, 13, 15. So a few things to know. The first one by default, so if you just give, let's say, set 5, the first number by default is 1 and not 0. And the last number is included, not excluded. So here 5 is also included. And if you have 3 arguments, then the second argument is the step. And the third argument is the like the upper limit. So if you have 5 to 15, it is 5 to 15 with 2 numbers being skipped each time. So we can also use sec in for loop. So this is simpler because we don't have to put any other brackets. But if you want, you can also use the output of sec. So I can do sec 110. And this is basically, we are running the command. And then on the output, we are running this for loop. So you can see the output is still the same. So we can use for loop to iterate over things like this. We can also use for loop to iterate over files. For example, here we have all these files. So if I simply do for I in star, so remember that star is a like shell glob that will evaluate to all the unhidden files in your directory. So this expands to this. So when I'm running this, if I do /script, you can see all the unhidden files in my directory are being printed one by one. Right. So what happens if, let's say, I change the IFS and I set it to the dot? then what becomes the output?
I have one question. Will star will always take ls as its command? If we
No,
put
star is not taking any command. Star itself is a bash glob that expands to the name of all the files in your current directory. So it does not use ls or anything. It by itself is something that is handled by bash.
Okay.
Yeah, so it will always expand into all the unhidden files in your current directory.
So it will not only take files but also the hidden files.
Yeah, it will expand to the name of the files. So files and directories both.
The output will be the same because you're not using IFS anywhere, right?
No, but I'm not using IFS, but the for loop will use the IFS. So let us see. Okay, so you can see here the dot which was there. So we had data.csv, output.txt, script.sh. They are now not there, right? So because I've set the IFS to be a dot, so now the dot as being treated as a field separator, so they are not being printed. So the for I in star is iterating over all these files, but when I'm getting the dot and I'm doing echo $I, so it is basically treating the data as one argument and CSV as another argument. So it's doing echo data space CSV. So we're getting this instead of data.csv. So if I remove that now, again, we will get the normal output. So here we can use star to iterate over all the files, but let's say I have a file which is, let's say, that starts with a dot. So if you have a file that starts with a dot, then if you do ls, it will not be shown. If you do ls minus a, it will be shown. You can see dot hidden. And similarly, if you do if you use star, then the hidden one will not be matched. So by default, star does not match any file or folder that starts with a dot. But you can, of course, use a dot star, so then it will match all the hidden files also. So it will match only the hidden files. So if I have another also, then 2. So if I do echo dot star, it will print only the hidden files. And if I do echo star, it will only print the non-hidden files.
If we need to use that while printing it or listing all the files in the directory, then we can. How do we use this combination?
If you want both, right? If you want hidden and non-hidden. So in that case, it's best to use ls minus a instead of using star. So for example, you can see if I simply run this script that we have, so now it's not printing hidden, and here if I do dot star, then it is only printing the hidden. But if I run it over the output of ls minus a, then it will print both the hidden and unhidden. So you can see these are also there and normal ones are also there.
So in the sequence place, we can leverage a command also like $ls minus a. So
So you can run any command here, and the for loop will iterate over the things in that output of the command.
Okay.
So for example, we have the command date. So I can also use date here. So I can say for I in $date and run this. So you can see it will split everywhere there is a space, right? So it will print wed in the first iteration, APR in the second iteration, 3, and then the time, etc. So we can put any command here, and the for loop will iterate over all the things present in that command. So you have to also make sure you're setting the IFS correctly. So here you can see that because by default it is like white space, it is splitting by white space.
So in this case, where is the white space? I mean,
these like between these, right? So the white space are
but in our command IFS, we have not given anything, right?
Yes, by default it will split by white space only. That is the default IFS.
It will split by space.
Any white space type, so space, tab, new line, etc.
Okay.
Right,
so and in this, where do we give IFS? In for IFS equals to?
Yeah, I think it's. I'm not sure. I think it's before for or after for. Let me see. So, for example, if I set IFS to be colon, no, I don't think it should be after for. Yeah, it should be working before for. Let's see. Okay, so it's neither before nor after. Let's see if it works if we give it outside. Yeah, I can see that the output of date is this. So it is splitting using the colon now. So it's taking from here till the colon as the first output, and then 35 as the second one, and then again from here till the end. So for the for loop, we have to set the IFS before the for loop. But then if you're changing it, make sure that you're again setting it back. So for example, if I now do for I in star, do echo $I, done. So in this case, it is working because we don't have a colon, but the IFS might interfere. So make sure whenever you're changing an IFS, make sure to change it back again to the old value of the IFS.
But it would be during that program execution only, right, sir?
Yes, yes. Outside it will revert back to the normal one.
With space, default IFS.
Yeah.
Sir, how to add this in for loop?
So this is, we have to define it outside the for loop. So you cannot put it in the for loop command itself. In the for loop, you have to use the IFS either outside, or you can set it like inside, but then it will be changed even outside the for loop.
Okay.
Right, so you can run any command here and it will go over those commands. So we can also iterate over arrays. So for example, what I can do is I can create an array this way, and I can store the output of the date as an array. So if I enclose something with round brackets, then that will be stored as an array. So now if I do for I in this, so this is how we access array elements. Right? So dollar, and then in curly braces we put the name of the array, and in square bracket we put @. So @ means all the elements of that. So now if I run over it, so you can see it is doing the exact same. So the output is still the same. So we can iterate over all the elements of any array. So for example, here let me set it to some other values like 1, 2, 3, 4, and we just call this array. So you can see that the output will be 1, 2, 3, 4. So what if I want to use one array element that has spaces in it? So I can use a quotation. So if I do this, then you can see that the output will not split on that. So even though there is a space between them, because we have quoted it, this entire thing is one element. So the array will have total of 5 elements, 1, 2, 3, 4, and this one, 5, 6. But when I'm iterating over it, we also have to put a quotation here. So if I don't put this quotation here, then the for loop will split it. So you can see it will print 1, 2, 3, 4, 5, 6. So because when I'm accessing an array this way with @, this will basically split the elements if I don't quote it. So I should always quote the expansion of an array so that this resplitting is not there. So you can see it is correctly printing all the elements in its own line. So if that is something you do want, that you want it to be splitted, so in that case you can remove the quotation. But in that case you don't actually need an array. You can directly treat it as a string. So you can use, instead of @ you can use star. So if you use star, the entire thing, the entire contents of the array will be given as a string to the for loop, and then you don't need to quote over it. So what happens if you quote over the star expansion is the entire thing becomes one element. So you can see now instead of having 6 iterations or 5 iterations, we have just one iteration where everything is present as a single iteration. So ideally you should never quote with star. So star you will keep unquoted, and when you have @, you should usually always quote it, because then it will give you the element correctly without resplitting. So if you have the @ expansion, then if you quote it, then it will come correctly. But if you don't quote it, then it will resplit the elements. You can see it will become like this.
Sir, one question here. typically in which of the ideally the array should have homogeneous elements, right? So if I have 1 2 3 4 like this and another one with 5 space 6, how what kind of a processing, or in which of the business use cases we will process like this, sir?
So in bash, there is nothing called integers. Everything is a string. So this 1 2 3 4 is also string. So everything is a string. So for example, let's say you're iterating over files, and these are the names of files. So I'm given 1 2 3 4 as an example. You can assume these to be some names like 1.txt, 2.txt, 3.txt, 4.txt, and you will oftentimes have files that have spaces in the names. So in that case, if you don't quote it, then it will split into two things, right? So for example, if I create something like hello world.txt, right? So this is one file. So if I open that hello world.txt, if I write hello world, this is one file. So if I basically go over all the output of all the files, and if I don't correctly quote it, then this will try to print hello and it will try to print world.txt. But obviously these two are not files that exist. There is only one file called hello space world.txt. So in that case, we should use arrays and then quote the arrays. So it should be like this, and then it will print it correctly. So let me come to another practical example. So instead of using an array, what we usually do is we also work with the arguments given to us. So we use the $@ to get all the arguments given to us as an array. So there are two things you can use. You can use $@ and $. So the difference is same as array expansion also. So if you use $, like all the arguments is treated as one string, and if you use $@, it is like a array. So if you quote the $@, it will correctly like split the elements as given. So for example, if I do script and then I give 3 arguments, as you can see, it's printing them one by one. But here, let's say I give one argument, which is a multi-word argument, right? So I have to obviously code it correctly. So if I code it now, you can see it is correctly printing that in one line. But here, if I don't use the quotation, then it will split it into multiple lines. So that is something you don't want in your script. So if you are working with some files or something, or even if not some files, but some arguments, and in some cases, if the argument is multi-word, then your script will fail. So you should always quote your $@. Or if you want it to be splitted, then you should use the $* instead. So you can directly use $, and it will split it. And if you want everything to be treated as one string itself, then you can code the $. So you can see everything is just one string.
Okay, sir.
Yeah. So this is one thing that is a bit difficult to understand. So I went over this. So usually when you're going over the arguments or going over elements of an array, usually what you want is you want to use $@, and you want to code that, because you want, if there is a space, you don't want to split with that space. So I cannot save this. So let us see another way of handling inputs and outputs. So usually we have seen how we can redirect in output using the greater than, how to redirect input using the lesser than. There are also some other things that let me quickly go over. So for example, we have, so let me use the cat command itself. So I have the cat command. So here I can give, let's say, name of a file. So I can give cat file. And if I have something present in a file, and then if I run the script, so it will cat that out. So I can also give the what to be printed into cat as a like standard input. So one way is to use the less than symbol. So it will give it as a standard input. So you can see the whatever I gave, like whatever is the content of the file, is first given to the cat command in standard input, and cat simply prints that. So another way to see this maybe is using the XSD command. So what XSD will do is it will print the hexadecimal version of whatever you are sending to it. If I run this, you can see that hello was sent to it, and this is how hello looks in hexadecimal. So if I run it this way, this will, it needs to have a file present in the file system in the current directory with this name. So for example, if I, let's say, give it data.csv, okay, so we have this data.csv, and if I run this now, you can see it is printing everything that is present in the data.csv, right? So we have this first line, then we have this 0a, which means a new line. Then we have the second line, then we again have a new line, and the third line a new line, and the fourth line and a new line. So this way, I am not giving the data.csv file as an argument to XXG, but I am directly giving it as a standard input to XXG by using the less than. But sometimes we don't have a file that we want to give as standard input, but we have some string itself that we want to give. So in that case, we can use the triple less than symbol. And here I can give any string that I want. So for example, I can give the string hello world. And if I do a triple less than symbol, then what bash will do is it will treat as if you're giving this string to standard input of this command. So if I run this now, you can see XXG correctly gets the input of hello world, and it is printing the hex dump of that. So this you can assume to be the same as doing echo comma hello world, and then piping it to XXG. Right? So the output of both will be the same. So if I run this, you can see both of them has the exact same output. So this is the output of first one. This is the output of the second one. So here we are using another command called echo. So this is a little inefficient, whereas we directly have a way of doing this in bash by doing this. And similarly, we can, so let me comment these two out. Similarly, as we saw, we can also use on a file, we can do, let's say, data.csv. So we can use the less than symbol, and this you can assume to be the same as cat data.csv and then piping it to XXG. So both of these are the same. So if I run this, you can see that both of them give the same output. So this is the output for the first one, and this is the output for the second. Sorry, this is the output for the second one. Both are identical. So this again is a redundant way of doing it, right? So this is inefficient because this is calling a command that is printing it to the standard output, then you're piping it to the standard input of this. Whereas you can directly do it using the bash way of redirecting a file as a standard input.
So basically here XSD is a file, right?
No, XXD is a command that prints hexadecimal output of whatever is given to it. The data.csv is a file.
Okay.
Yeah, and similarly, you can give a string as standard input by using the triple less than symbol. So that is same as echoing some string and giving it as the standard input, but then this is inefficient. So this is a better way of doing this. You can see this gets that as a standard input. Another way, so here we saw two things, two ways of sending standard input. One is sending a string as standard input. So let me just list them down. Sending a string as stdin. Then we saw sending a file as stdin, which is xxt less than data.csv. We also can send output of any command as a so it's not as a standard input, but as a file. So obviously we can send output of any command as standard input. For example, I can do ls pipe xxt. So this is sending a command's output as standard input to another command. So we are already familiar with this one. So what this does is it runs ls, and then the output of that is printed to the it's redirected to the standard input of xxt. So if I run this, you can see. Let me comment all these out, other ones, or let me delete temporarily. So you can see that it is printing all the things that we have in our ls, right? So we have A, B, C, D, data.csv, file, hello world.txt, list1. Right, so all these you can see are the new lines. So it is giving A and then new line, then B new line, C new line, etc. So this is sending the output of a command as standard input to xxt. But another thing you might need to do is sending the output of a command as a file. So some commands do not take standard input. They only take from a file. So one example of that is the diff command. So we've seen the diff command in our synchro evaluation, right? So what is the diff command? It simply shows the difference between two files. So for example, if I have the A and I have this is file A, and okay, so let me create some other file. So let me have diff1, which has 1, 2, 3, 4, 5, 4, 7, 8, 9, and I have a diff2 file which has 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I run diff for the files diff1 and diff2, then you can see what it will show you is the difference between the two files. So you can see the first and third line are same, so that is not shown. Only the second line is different. So it's telling that the second line of both the files, it's changed. So here it is 454. So the left file. So you can see the left angle bracket means the left file. So the left file, which is diff1, has 454. Whereas the right file has 456, which is the diff2. So in diff, you can only give something as like file. You cannot give as a standard input. So how can I give the output of some command as standard input? So sorry, output of some command as a file. So that we can do using the less than and then round brackets in there. So for example, I can do diff, and then here I can do ls, and here maybe I can do ls on some other place. So maybe ls dot dot. So here you can see that the difference between ls and ls dot dot are being shown. So ls is obviously files in the current directory, which is all these, and then ls dot dot is files in the parent directory, which is all these. So let me maybe create two directories to make it more clear. So let me create, let's say, dir1 and dir2, and let me in dir1 let me add A, B, C, and D, and in dir2 let me add C, D, E, F. Okay, so you can see currently what we have is we have the dir1 folder which has A, B, C, D, and dir2 folder which has C, D, E, F. If I do ls dir1, I get A, B, C, D. So like by default it will be like this. And if I do ls dir2, it will give me C, D, E, F. So if I want to see the difference between the output of these commands and not some file. So one way is I can obviously like store the output of dir1 into, let's say, some PMP file, and I can store the output of dir2 as some PMP file, and then I can do diff PMP1 and PMP2. So that is possible. So here I get the output like differences. A and B is there in the left file, and E and F are there in the right file, and obviously C and D are common in both of them. But here then we are using a temporary file in our current directory, which is creating a lot more clutter. So instead of that, what I can do is I can directly run diff with both the outputs. So that is done by using the angle bracket round bracket notation. So here I can do ls dir1, ls dir2, and what this will do is it will execute this command ls dir1, and it will store it as a temporary file, and it will then give that temporary file to diff. And similarly, it will execute this as a temporary. This will execute this command and store its output as a temporary file, and give the path of that temporary file to diff again. So here you can see the output is same, but we did not create any file in our current directory. So our current directory remains clean, and we still are able to execute a command and give its output as a file to diff. So where are these temporary files stored? You can see that by using echo. So you can see that if I do lsdir1, you can see that this whatever I ran, that output of that resides in a file in /dev/fd/60. So it's actually not a real file. It is like a pseudo file. So whenever you try to read from it, it will provide you the each line one by one, but it does not store it in the file system. So how it works is not required for us to understand, but then how the syntax works is important. So sending the output of a command as a file, the example of that is this one. So ls. So this can be any command. I'm just demonstrating with the ls command. Hopefully this makes sense. Okay, so just let me know if this makes sense, then we'll move on.
So here first the dir to ls, I mean, both the things run simultaneously, or what is it? Like it's just diff takes A
Yes.
and B. So basically these are the two. ls dir1 is basically my first argument.
Yes.
And then ls dir2 is the second argument. So this is essentially saying if two directories contain any different files.
Yes,
Right?
yes, exactly. So
One
how
is in
this
dir1,
works
but not
is
two.
they will be running simultaneously. So the ls will be run, and its output will be stored in a named pipe or a FIFO. So I don't want to go into what those are, but then it will be stored in a named pipe, which is kind of like a file, but not actually a file. So it will keep on feeding each line. So ls also will print line by line, right? So it happens so fast that it seems instantaneously, but ls prints its outputs line by line. So this ls will print its output line by line, and that will be stored in that FIFO file. And this ls will also print it. So both of them will be run simultaneously. And this will also print line by line, and that will be stored in the FIFO file. And then diff will be told that, okay, this is the file /dev/fd something, and this is the other file /dev/fd. So those are the FIFO files. And then diff will read. So diff also reads line by line. So diff also obviously cannot read totally. So this diff will also read line by line. And whenever diff tries to read one line from the first file, then ls has sent the first line. So it depends on the speed of the commands also. So if let's say this is a command that takes a lot of time, so let's say this takes 10 seconds to print even one line. So then diff, when it's trying to read that first line, it will keep on waiting. So it will wait till that first line is available. And then as soon as that first line is available, it will take that first line, and it will then take the first line from the other file, and it will compare the difference. Right? So all of them occur simultaneously, but because we are running commands that run very fast, it looks like we are not able to see the difference. But if you, let's say, run some command that takes a lot of time, you can see that it will take some time to print one line, then it will take some time to print the next line. So this occurs simultaneously, and all the three will be running, and it will give each line one by one to the diff command.
Sir, one doubt. So if we do man diff command, then it will have two types. One is diff file1 space file2. The other syntax is diff the command.
Yeah. So diff. No. So this is not like a different way to do something in diff. This is a bash syntax. So you can do this for any command. So you can run any command, and you can give it as a file to any command. So this is not unique to diff. As I showed, we can do it with echo also, right? So I can execute some command, and that will be stored in a named FIFO file, and that will be then that argument will be given as an argument to echo. So for echo, this is just a string. Similarly, for diff, this is just a file, like a path to a file. Diff does not know if I am running it this way or I am storing it in a file and giving. Right? So the diff only has one way of operating, which is using files.
Okay. What about the option in the diff, sir? We have -q, -s.
Yeah. So these are the different options to change the behaviors of diff. So for example, you can change the behavior. So you can show the two outputs side by side, output in two columns. So for example, if I do diff, we have diff1 and diff2, right? So what happened to those files? Yeah, it's there. So if I do diff1 and diff2, so here it's only showing the lines that are different. But if I do -y, you can see it will show them side by side. And because this line is different, it's showing a line here, whereas these two are same. So that's why this is same. So, but it's showing entire thing, and it's showing them side by side. So here you can see it's showing the left one, and then it's showing the right one, and it's only showing what is different. Whereas in here, it's showing both of them side by side.
So we only have to manually identify which one is the difference.
Yeah, if you're using Y, then no, it will show you this line. You can see this white line.
Okay.
So it will show you which lines are different. So if you want to see the entire file side by side, then you can use diff Y. So usually we use diff in the default mode to only see if there is any difference. So for example, if I use diff on the same file, then obviously there is no difference. and we also don't get any output. So that is usually how most Linux commands work. So if everything went on correctly, it should not print anything to the screen. Only if there is an error or some issue, then it prints. So here also you can see the exit code will be 0. And if I run diff1 and diff2, then you can see the exit code will be 1. Okay, so the exit code also lets us know if there is a difference. So because it gives a exit code, we can use this in if as well. So that is why we have this queue. So you can see if I do diff1, diff2, if I do queue, it will just print this, but it will not show the difference. So you can also, I think, suppress the entire thing. I'm not sure. Or you can obviously always use like redirection to def null. So you can redirect everything to def null. So even if there is a difference, it's not showing anything, but we can get to know that there is a difference using the exit code, right? So I can put it in a if condition. So I can do if diff1, diff2, and I don't want to see what is the difference. I can put this in def null. Then echo there is some difference. Else echo there is no difference. Okay, so okay, I forgot to close something. What is it? Okay, yeah. I forgot to put a semicolon here, and also somewhere else. Yeah, yes. Okay, so you can see that it says there is no difference. Okay, why is this? I think there is no difference. Yeah, sorry. So the exit code will be 1 if there is some difference, and the exit code will be 0 if there is no difference. So you have to basically do this. So you can see there is some difference, but if I run it on diff1 and diff1 itself, then it will say there is no difference. Right, so we can use the exit code of diff directly in a if condition. So you can run any command inside if, or you can run any command inside the while. So let us also see that in a script itself. So this is the one for the outputs and input. So let me also create another file now. Close these. So here if I, let's say, I ask the user to give the 2 files, enter file 1, and I can do read p, enter file 2, and then what I can do is I can do diff file 1 and file 2. So I can also put this in a if conditions. I can do if diff file 1 and file 2, that is there is no difference. Then I can do there is no difference. And else we can say echo differences are printed above. So this way we can interactively ask the user for files. So for example, if I so we already saw we have 2 files called diff1 and diff2. So these have one line which is different, everything else is same. So here if I run this script, so you can see it's asking me for file 1. Here if I give diff1, and again if I give diff1, so obviously both the files don't have any difference. Why is this happening? Missing operand after if. Okay, sorry, my bad. I forgot to give the name of the variable. I put file 1, and this is file 2. So they are stored in this file 1 and file 2. So yeah, let's try that again. So if I do diff1 and diff1, you can see it's telling there is no difference in the files. But if I run it and I do diff1 and diff2, then you can see, first of all, the difference are being printed because I have not silenced the output. I have just run the command, right? So I did not do greater than def null. So I have not silenced the output. So the output is printed. And then also we are telling difference are printed above. That's because the diff is giving us a non-zero exit code. So we are going into the else part.
Sir, I got a bit confused. Could you repeat this for me?
Yeah, which part?
This the second output and the difference between the first output and the second output.
So the first output we are giving both the files as diff1 itself. So it's trying to find the difference between diff1 and diff1. So obviously there is no difference between the same file. So the diff will return a 0 exit code if there is no difference. So then we are coming here and we are telling there is no difference. But if we are giving two different files, then here, so it can also be same. So two different files can also have exactly the same contents. Then also it will say there is no difference. But here they have one line which is different, right? So the second line. So here what it is doing, it's printing that difference, and it's coming to the else part. So it's telling difference are printed above.
Okay, and one more doubt. A few minutes back, we saw about the hexadecimal representation of a file, right, sir?
Yeah.
Do we use such kind of notion during encoding and decoding, or in which of the scenarios we will leverage such commands?
Yeah, so it is very useful, especially for debugging. So for example, let's say I am running to, like, let's say I'm doing something like this, right? So I'm doing a diff, and I am getting that there is a difference between two files, right? So I don't have something in my hand right now to show, but just bear with me. Let me add something here. So let me just open a file called LF. And what I will do is, I want to create another file that has some other characters. So 1 second, let me just copy that and open that. So I'm not sure if I can do it in this frame. Okay, so if I do LF, the like diff of the LF and the LFT, we can see it's telling me that these two lines are different. But from seeing this, can you understand why it's different, or what is difference in these? It's not possible, right? So obviously there is something difference. Otherwise, like the diff command would say that they are same. If I just
do this tr minus substitute blank space with something else, maybe there are some blank
yeah,
space.
we can do that, but instead of like guessing, what we can do is we can use the XXD to directly see what the hexadecimal is, right? So if I do XXD LF, I can see what there is, and I can similarly do XXD LFT. So here you can see what is the difference. So here you can see that it was telling that the line which has U, it has some difference. So here you can see this one has YOU and then this dot, which is 0A, which is the new line. Whereas here we have YOU and then dot dot. So here we have 09 and we have 0A. So this is basically a tab character. Sorry, so this 09 is a tab character and then 0A is a new line. So in this file, we just have new lines. So we have this line, then a new line, then this line, then a new line, and then this line and a new line. Whereas here we have also a tab character before the last new line. So that is what I added, but just from this diff, you cannot see what is the difference. But if you're doing XXD, then you can see the difference. But here also, assume this was like a million lines of file. So diff is only showing you the line that is different. So that is useful. But here you cannot visibly see what is the difference. And XXD is showing you the hexadecimal. So you can see exactly like how something might be different. But assume this was a million lines, then XXD output would also be very long. So scrolling and seeing what is the difference would also be very hectic. So there you can combine them. So what you can do is you can do XXD LF and you can do XXD LFT. So these two XXDs will print these two things, and then you're running a diff on the output of those, right? So then it will be even simpler. So you can see the entire output of XXD is not shown, only the place where it does not match. So here you can see only this part. So it is U and then dot, and it's this U and dot dot. So here you can see exactly which place you have a mismatch. So here it is just the U character, which is 75, and OA, which is new line. And here it is 75, tab, and then a new line. Right? So this is very useful of like when you're trying to debug why something is not working, or why you're seeing both the lines as same, but then there might be some unprinted characters, right? So you can see exactly what hexadecimal character there is.
Even if I have multiple differences in the same file, at least we can get a catch.
Yeah, so it will show you all the differences. For example, if I add, let's say, another tab somewhere. So I added it here after U. If I add it after hello also, Right, so now if I do diff lf and lft, you can see it's telling hello line is different and u line is different, but I don't know what is the difference. But if I do with xxg, you can see it's telling, okay, both these lines are different, right? So here you can see that you have this 6f0a, whereas here you have 6f090a. So here we have a tab here, which we don't have here. Right, hopefully this makes sense.
Yeah.
So this is very useful when we are trying to see exactly what is stored. So even it also helps in the encoding. So if the file is encoded as ASCII, you will see something. If it is encoded as UTF-8 or UTF-16, you will see a different hexadecimal representation. So if you like, if you're working with encodings and you know how encodings look, you can easily see the output of XXD and understand what the encoding is. So there is also something called like little endian and big endian. So I'll not go into the differences, but then it's the way you store the bytes. So whether you're storing bytes one after the other, or you're storing it in a like weird manner. So like either you're storing it like 1, 2, 3, 4, 5, 6 like this, or you're storing it something like 2, 1, 4, 3, 5, 6 will become 6 like this way. So this is usually how, so this is how it is usually stored when it's transmitted over the internet, and this is usually how it is stored in most operating systems, so Linux, Windows, Mac, etc. So they store it in like this twisted manner. So 2 bytes will be stored in the reverse order, then again next 2 bytes will be stored in reverse. So these also you can easily see if you are printing it using XXD. You can see how it is stored. So that is pretty much it for the scripts and regex. So as it is already 9, let us cover the sed and awk in the next session. So we'll have another revision session on Saturday. We also have a TS session on Friday. So we will cover these on those 2 days.
So where is it possible to find these recordings?
The recording will be available a few hours later in the calendar, and we'll upload it in the YouTube. So we'll also send the link. So that will also be there in the calendar.
Yeah, that is better actually, because when we get it as part of calendar, it doesn't buffer. I mean, it doesn't play as easily as YouTube.
Yeah, like if it's in the Google Drive, it's hard to play. But if it's in YouTube, it is more optimized.
Yeah.
We'll upload it, but it will take some time. So you can assume by tomorrow.
Okay, sure.
Hello.
Thank you so
Yeah.
much.
Sir, I was just writing an awk script and